So let's start on lesson 5, dividing radicals, part 2. So what we looked at the other day is we rationalized the denominator. There was only ever one term in the denominator. So the question that comes up, what happens if I have two terms or a binomial in the denominator? So in lesson number 3, if I pull lesson number 3 up quickly, there was a couple of questions that talked about the conjugate. Right here. The conjugate binomials are pair of binomials in the form of a root b plus b root d and a root b minus c root d. So they're the exact same expression, only one's positive and one's negative. And what I get is I get a difference of squares. So when I go to multiply these out, it's the same as multiplying the first terms and multiplying the last terms. The outside and inside terms end up canceling each other out every single time. And you had questions like that. So for example, if I had this and I wrote the conjugate's going to be negative 3 root 11 minus root 2. And then when I multiply it out, I've got 9 times 11, because root 11 times root 11 cancels. If I was to multiply this negative 3 root 11 by negative root 2, I get a positive 3 root 22. When I multiply these two together, there's my negative 3 root 22, which ends up canceling. And then my last two terms, root 2 times root 2 gives me a negative root 2. So I get 99 minus 2, and I get 97 for an answer. So I no longer have a radical in position. And that's what we're trying to do. When we're trying to rationalize the denominator, we're trying to get rid of the radical forms. So that's what we're going to do with these questions, is we're going to multiply by that conjugate. So what's the conjugate of root 5 minus root 3? And in order to keep the expression balanced, I need to multiply this by 1. So if the bottom is root 5 plus root 3, the top has to be root 5 plus root 3. Because together, if I take something and divide it by itself, I get 1 as an answer each time. So if I take the top, for now, we can just leave it in factored form. And then if I look at the bottom, what's root 5 times root 5? And negative root 3 times root 3? And what's 5 minus 3? So I get 2 times root 5 plus root 3 over 2. What's 2 divided by 2? 1. So I'm left with root 5 plus root 3 as a final answer. And that's part of why we leave the numerator factored until we're done, just in case we could cancel out a common factor. So if I look at B, what is the conjugate that I would be multiplying by in B?
Root 6 minus 2.
Thank you. And then the top would be the exact same, so that the whole thing equals 1. So when I go to multiply this out, I know when I multiply the bottoms, because they're the conjugates, I only have to multiply the first terms and the last terms. The top is not a conjugate of each other. They're the exact same expressions. So when I go to multiply this out, I have to think in terms of my distributive property. So root 6 times root 6 gives me 6. Root 6 times negative 2 would give me a negative 2 root 6. And then I get another negative 2 root 6. And negative 2 times negative 2 would give me a positive 4. At this point, I can collect like terms just to clean everything up. So on the top, I have 6 plus 4, which is 10. And 2 negative 2 root 6s will give me negative 4 root 6. And 6 minus 4 will give me 2. At this point, can I divide the 10, the 4, and the 2 by a common factor? Yes. So I get 5 minus 2 root 6 over 1, which I don't need to put in. I don't divide the root 6 by 2 because it has to be coefficients. I'm dividing coefficients here, not radicands. What's my conjugate that I'd multiply by in C? Anyone?
1 minus root x.
Not 1 minus.
Oh, plus.
1 plus. I know that's what you meant to say. So if I multiply the top, 1 times anything is going to be what I have. So I'll have 1 plus root x on the top. And on the bottom, because they're conjugates, I'll again multiply the first terms and multiply the last terms. So when I take root x and I multiply it by root x, I get x. So class example number 2 says express the following with a whole number in the denominator. So I have root 8 minus root 3 over 4 root 3 minus root 2. A whole number in the denominator is just another way of saying rationalize the denominator. So if I rationalize the denominator, what would I multiply the top and the bottom by?
4 root 3 plus root 2.
Yep. So again, using the distributive property. Root 8 times 4 root 3 would give me 4 root 24. And then root 8 times root 2. Negative root 3 times 4 root 3. And then negative root 3 and positive root 2. And then on the bottom, if I multiply 4 root 3 by 4 root 3, not 4 times 3. I've got the 4 times 4.
16 times.
So I get 16 times 3. And then negative root 2 times root 2. Minus 2. So on the top, we're going to have to try to simplify. So let's start off with our root 24. Does root 24 have a perfect factor in it? 4 times what?
6.
What's the square root of 4? Times 4 is 8. So this will become 8 root 6. What's the square root of 16? It's the square root of 9 times 4. And 16 times 3. And 48 minus 2. Okay, we're not done collecting like terms. 8 root 6 minus root 6. and 4 minus 12. Can I divide all of my coefficients by the same value? No. 7, 8, and 46 don't have a common factor. So this would be as simplified as I could make it. I don't want to split this up and look at just reducing the 8 and the 46. I want to be able to reduce all three or divide all three by the same factor. Class example number 3. The area of a trapezoid is given by the formula A equals 1/2 h times the sum of a plus b, where a and b are the lengths of the parallel sides and h is the shortest distance between the two sides, or in other words, the height. If the area of a trapezoid is 20 square centimeters and the parallel sides are of length root 6 and root 5, determine the exact value of the distance between the two parallel sides, answering with a rational denominator. So here's my formula. So I'm going to substitute in with what I know. Do I know the value of the area? Okay. H I don't know. And A and B I have as root 6 and root 5. So my goal is to get H by itself. So to get H by itself, I have to get rid of the 1/2. How do I do that? Times by 2. So if I multiply both sides by 2, I'll get rid of the 1/2 on the right side. And on the left side, when I multiply by 2, I will get 40. And then how do I get rid of this root 6 plus root 5? I divide. So that's the value of h with rational or irrational denominators. If I want to make it a rational, I would have to multiply this by the conjugate. And what would the conjugate be? So because I only have the one term, I can leave them factored out, or I can leave them separated. It's only when I have the two terms that I would do my distributive property. When I multiply the bottoms, what would I get? Yep. And what is 6 minus 5? 1. And do I need the 1 there? So this would simplify to 40 times root 6 minus root 5. And if you were to do decimal approximations, if you went 40 divided by root 6 plus root 5 and got that as a decimal answer, and then went 40 times root 6 minus root 5, you'll get the same decimal. Questions for you to work on. Question number 1, B and D. 2A, 3B, 4A and D, 5A, and then 7 to 12, which are the multiple choice and numerical response.